Uh, Homework 10, sum number 1. According to the homework, we are supposed to find out the various properties of various functions. The various properties are probability masses, mean and autocorrelation of the following functions. The first one is the Poisson process. Now, the probability mass of the Poisson function can be easily found out by using the simple equation. For equations xt1 minus xt2, it is given by e raised to minus lambda t1 minus t2 into lambda t1 minus t2 raised to k upon k factorial. And the following is the diagram of a simple Poisson process. Its mean can be easily found out by using the various formulas. It has been found out over here. It is given by e into e of xt is given by lambda t square plus lambda t. Now it is we can explain it by using the time intervals and the buses. So the number of buses between a specific time interval is known as a Poisson process, like between 5 and 25 minutes what number of buses will arrive. So now we are finding the autocorrelation function, which is given below. Our t1 t2 is equal to lambda square t1 t2 plus lambda min of t1 and t2. Its variance is given by lambda t, and there are actually two more possibilities for overlapping and non-overlapping terms or time intervals. Of if the time intervals TATB and TCTD overlap each other, then the following equation can be used, and if they don't overlap each other, the above equation can be used. Now the second one is Poisson increments. Poisson impulse this is Poisson increments with xt Poisson process defined above a constant sigma greater than 0, then the whole process can be found out as yt is equals to x of t plus sigma upon sigma minus x of t. Now the probability mass function can be also given by using the same formula which we use for Poisson process. It is given by e raised to minus lambda sigma into lambda of epsilon raised to n upon n factorial. Sorry, this is not sigma, this is epsilon. Now finding the autocorrelation functions, there are actually two possibilities. If the interval t1 minus t2 is greater than or equal to epsilon, or t1 minus t2 is smaller than epsilon. Here are the two equations for defining autocorrelation functions. The first one is lambda square, and the second one is given below, which is lambda square plus lambda upon epsilon minus lambda into t1 minus t2 upon epsilon square. Now the third process is the Poisson impulses. Poisson impulses can be easily found out by applying a limit to the Poisson increments, and its mean is given below. Applying or taking the derivative of the Poisson process, we get d by dt of lambda t, which is equal to lambda. Similarly, the autocorrelation function can also be found out by applying the double derivative, that is d of dt1 into d of dt2 into lambda square t1 t2 plus lambda min t1 of t2. Now we find out the the various properties of random and semi-random telegraph signal. So here is a signal. If x0 of the signal is fixed at 1, we call it a semi-random signal, and if it can be 1 or minus 1, we call it a random telegraph signal. So first, finding it out for the semi-random telegraph signal, it is given as 1 if k is even in the time interval 0 to t, and minus 1 if k is odd. Now similarly putting it in the equation, we get 1 for the even number of terms. So taking the number of terms even, we get e raised to minus lambda t into 1 plus lambda t raised to 2 upon 2 factorial plus lambda t raised to 4 upon 4 factorial, and so on. And this is actually the hyperbolic function, so it is given as e raised to minus lambda t cos h of lambda t. Now similarly we found it for the odd number of terms. We get -1, which is given right here, which is equal to e raised to minus lambda t sine of h lambda t. Now to find out the mean, this is the following equation, and substituting the values we get e raised to minus 2 lambda t. Now if t1 is greater than t2, finding the autocorrelation function, we get e raised to minus 2 lambda t2 minus t1, and similarly if t2 is greater than t1, we get e raised to minus 2 lambda t1 minus t2. So all in all, it can be given as e raised to 2 lambda modulus of t1 minus t2. Now finding it out for the random telegraph signal. The random telegraph signal is right here. We consider it for the probability is of getting 1 or -1 is half. So we are forming a new process right here. Y of t is equals to a constant into x of t. Now the random telegraph signal is also given by the following process. Here this is a constant term, so the mean of the constant term is 0, hence the whole term gets converted into 0. Now similarly our t1 t2 can be found out the same way, and the square of the constant is 1, and this one we can take it from the semi-random telegraph signal, which we already did. So we get the answer e raised to minus 2 lambda into t1 minus t2. So we have completed a random telegraph signal and semi-random telegraph signal. Now we move on to random walk. Random walk can be found out or considered using the example of tossing a fair coin. If the coin is tossed infinite number of times, then the number of heads or probability of getting it can be defined by the following equation. This gives the number of heads. It is plus s if we get a head and minus s if we get a tail. So here are the various properties. This is the mean, and which is given by minimum of n in n comma n into s square. So this is random walk, and this is the last and the final process for which we are supposed to find out the properties, which is the Wiener process. The Wiener process, the mean is found out by the following formula, and applying limit to it we get alpha into t, where alpha is considered to be a constant. Now again applying limit, we can find out the following equation. So we find out that the mean is 0, and similarly we find it for the autocorrelation function, which is given right here. So we have found out all the properties of all the processes given here, and this is the end of the video. Thank you.